Like fellow gas giant Jupiter, Saturn is a massive ball made mostly of hydrogen and helium. Saturn is not the only planet to have rings, but none as spectacular as complex as Saturn is. Saturn also has dozens of moons. From the jets of water that spray from Saturn's moon to the methane lakes of smoky Titan, the Saturn system is a rich source of scientific discovery and still holds many mysteries. Saturn is the farthest planet from the Earth discovered by the unaided human eye. Saturn has been known since ancient times. The planet is named for the Roman god of agriculture and wealth, who was also the father of Jupiter. Saturn's environment is not conducive to life as we know it. The temperatures, pressures, and materials that characterize this planet are most likely too extreme and volatile for organisms to adapt to. While planet Saturn is an unlikely place for living things to take hold, the same is not true for some of its many moons. Satellites like Enceladus and Titan, home to the external oceans, could possibly support life. With an equatorial diameter about 74,897 miles, Saturn is 9 times wider than Earth. If Earth were the size of nickel, Saturn would be about as big as volleyball. From an average distance of 886 million miles away, Saturn is 9.5 astronomical units away from the Sun. It takes sunlight 80 minutes to travel from the Sun to Saturn. Saturn has the second shortest day in the solar system. One day of Saturn takes only 10.7 hours, the time it takes for Saturn to rotate or spin around once. And Saturn makes a complete orbit around the Sun, a year in Saturn time, in about 29.4 Earth year. Its axis is tilted by 26.73 degrees with respect to its orbit around the Sun, which is similar to Earth's 23.5 degree tilt. This means that, like Earth, Saturn experiences seasons. Saturn is a home of vast array of intriguing and unique worlds. From the haze-shrouded surface of Titan to crater-riddled Phobos, each of Saturn's moons tells another piece of story surrounding the Saturn system. There are 146 moons in orbit, with others occasionally continuing confirmation from the discovery and official naming by the International Astronomical Unit. Saturn's rings are thought to be pieces of comets, asteroid, or shattered moons that broke up before they reached the planet, torn apart by Saturn's powerful gravity. They are made of billions of small chunks of ice and rocks coated with other materials such as dust. The ring particles mostly range from tiny, dust-sized icy grains to chunks as big as a house. A few particles are as large as mountains. The rings would look most white if you look at them from the cloud top of Saturn. Interestingly, each ring orbits a different speed around the planet. Saturn's ring system extends up to 175,000 miles from the planet, yet the vertical height is typically about 30 feet. In the main rings, named alphabetically in the order they were discovered. The rings are relatively close to each other, with the exception of a gap measuring 2,920 miles. Starting at the Sun, Saturn, and moving upward, there are rings. Saturn took shape when the rest of the solar system formed about 4.5 billion years ago, when gravity pulled swirling gas and dust into become this gas giant. About 4 billion years ago, Saturn settled into its current position in the outer solar system, where it is the sixth planet from the Sun. Like Jupiter, Saturn is mostly made of hydrogen and helium, the same two main components that make up the Sun. Like Jupiter, Saturn is made mostly of hydrogen and helium. At Saturn's center is a dense core of metals like iron and nickel surrounded by rocky materials and other compounds solidified by intense pressure and heat. It is enveloped by liquid metallic hydrogen inside a layer of liquid hydrogen, similar to Jupiter's core but considerably smaller. It is hard to imagine, but Saturn is the only planet in our solar system with an average density that is less than water. The giant gas planet could float a bathtub if such colossal thing exists. As a gas giant, Saturn doesn't have a true surface. The planet is mostly swelling gases and liquid deeper down. While spacecrafts would have nowhere to land on Saturn, it would be able to fly through unscattered either. The extreme pressures and temperature deep inside the planet would crash, melt, and vaporize any spacecraft trying to fly into the planet. Saturn is blanketed with clouds that appear as faint strips, jet streams, and storms. The planet's many different shades of yellow, brown, and gray. Winds in the upper atmosphere reach 16,000 feet per second. In the equatorial region, in contrast, the strongest hurricane force wind on Earth top about 360 per second. And the pressure, the same kind you feel when you dive deep underwater, is so powerful it squeezes gas into the liquid. Saturn's North Pole has interesting atmospheric features, a six-sided jet stream. This hexagon-shaped pattern was first noticed in the images from the Voyager 1 spacecraft and was been closely observed by the Cassini spacecraft since spinning about 20,000 miles per hour across. The hexagon is a storm at the center. There's no weather feature like it anywhere else in the solar system. Saturn's magnetic field is smaller than Jupiter's, but still 570 times as powerful as Earth. Saturn, the rings, and the many of the satellites lie totally within Saturn's enormous magnetosphere, the region of space in which the behavior of electrically charged particles is influenced more by Saturn's magnetic field than by the solar wind. Aurora occur when charged particles spiral into the planet's atmosphere along magnetic field lines. On Earth, these charged particles came from the solar wind. Cassini shows that at least some of the Saturn's aurora are like Jupiter's and largely unaffected by the solar wind. Instead, these aurora are caused by the combination of particles ejected from the Saturn's moons and Saturn's magnetic field rapid rotation rate. But these non-solar originating aurora are not completely understood yet. So, planet Earth is fascinating. Please continue to be part of our family here because we will continue our discovery as usual, as every day. For those who are interested more in science, learn more about space, we're here. We're here to discover. At the same time, just to be part of the program for those who will be getting the first to know. So always look up there. There's always something, always